I'll start. So yeah, good morning, everyone. Hope everyone is all well and good. Welcome to our virtual coffee morning today. It's the first virtual coffee morning we've done. We've done coffee mornings obviously in the past, but normally they're together somewhere, normally a bit earlier in the morning, but this is the first virtual one. So I'd just like to welcome you all and just cover off a couple of things. Hopefully you've all got your tumblers. So I've got mine. I've got my tea in there as well, half drunk. So hopefully you've all got your tumblers. These, I don't know if some of you might have these already. You know, different tumblers. They're pretty cool. Nice. Keep your hands cool when you're drinking hot drinks. So you got those. And if you haven't for any reason, then just let Sandy or myself know. We'll get you one sent out, but you should have them, and you should also have your macaron, yeah, not macaroons but macaron. I've only had one, just so you know. I've only had one, but the kids have been at mine, so they're kind of quite depleted. I've had one, which was the birthday cake one, which was really nice. But yeah, hopefully you'll enjoy them. Hopefully your family, friends, and stuff will enjoy them. So yeah, let's crack on. So we've got half an hour, or just a bit less than half an hour now. So it's not a huge amount of time. So the point of today is to talk about DevOps, and what I want to do really is I want to explain some of the kind of basics of DevOps and the kind of all-encompassing view that DevOps can have. And what I like to do is I like to enable people, or enable anyone, so that hopefully what you guys can do is take away anything you've learned from today, anything that you've picked up, and then be able to make decisions or be able to look into something in a bit later. I appreciate that we're not going to go into huge amounts of technical detail here, because that's not the point of this session. Some of you are techies, some of you are not. We all generally work in the kind of the technology industry, and some of you will be using some of the DevOps techniques or applications that we're going to cover. But the key thing is, in order to make business decisions and get the outcomes that we want, I think it's very important for us to have an appreciation of some of the basics, and that's what I want to really do, is cover off some of the basics around DevOps specifically. And I hope that this session will be of benefit to you. So normally I'll do a little bit of an intro on myself, but the attendee list, we know the attendee list. You all, pretty much all of you have either met me already or you know of me. But just to, very basically, my name's Amir Hashmi, and I'm the CEO of Shah Limited. So we're partnered, or with many of you already. You guys know us to some capacity, but what I'll do is I'll dig straight in, and what I'll start with is I'll just define. I wanted to just define what DevOps is. DevOps is a term that comes up quite often, depending on which sector you work in, but DevOps comes up all the time when it comes to technology and cloud specifically. So what is DevOps? DevOps joins IT operations and development. It kind of joins them like this. That's just a simple way to look at it. But what does DevOps actually kind of do? The key word, if there's one word to remember around DevOps, there are many, but the one, I think the main one, is automation. It delivers automation to us. So it delivers automation around application deployment, around application management, and what it does, it through that automation, it increases our reliability, it increases our repeatability, and it increases speed when it comes to deployment, when it comes to application delivery. Increases speed as well. So that's a very brief and very loosely defined kind of definition of DevOps. The key thing is it automates, and hopefully what I'm going to do is, as we move forwards, you're going to see a lot more around that. the next point, we've got is DevOps and how DevOps links with cloud computing. Then we've got why DevOps is leading teams to the cloud. And then we've got DevOps use cases. Half an hour, we're most likely not going to get onto the use cases. We do have some prepared, but I don't think we'll get onto them. So what we can do is we can arrange a follow-up session. We can either do a general one, or feel free to contact Sandy or I directly, and we can do a private session. We can catch up, and we can send you some information and obviously talk through things. But we'll certainly cover the first three. We're going to cover everything with the aid of one diagram, which I'm going to come on to in a second. And I'm just going to talk through this kind of the life cycle, or all the kind of pieces that come together that make up a comprehensive view of what we call kind of DevOps. So what I'll do is I will actually just move to this next slide. So hopefully you can all see this diagram. So I'm going to use this diagram to kind of answer all the kind of questions that we had on the previous slide, and hopefully the aim is to give you a kind of, to use a cliche, a 360 view of what DevOps is and what actually goes into the whole DevOps kind of buzzword, but also how cloud plays a part in it and how it affects us and our teams. So let's start. Let's start on the left. So if we look on the left where we've got code, and we look at, we can look at the names of the vendors, and that's what we're trying to show you. We're trying to show you the different sections or the different areas that DevOps has an impact on or creates. And then what we've got is we've got some vendors that operate in that space. This is not an exhaustive list. This is a list of some of the most popular, but also very specific to us, many of the kind of vendors and technologies that we use that we're very expert with, for example. So again, some of you know this already, but we do DevOps, and we do DevOps for some of the biggest brands, some of the biggest names and brands in the world. And we do small pieces of kind of DevOps deployments or design through to full kind of DevOps auditing and architecture and managed DevOps for organizations as well. So this is not an all-encompassing view, but it covers the bulk of the kind of major kind of players and the major areas around DevOps. So let's start with code. Applications normally start with code. Before code you do design, etc., but applications normally start with code. So in the DevOps world, what do we use for our code? We use things like GitHub, GitLab, and Bitbucket. Git itself, so if we just take the word Git, it's not a rude word in this instance. If we take the word out, Git itself is a software application that's used to manage our code. So when developers are typing their code, in order for them to collaborate with another developer that might be in the building or might be in Singapore or the US or wherever they might be, they need some sort of a software platform that allows them to collaborate on writing their code, putting all their code together, having different versions, making sure there's no repeats and clashes. You need that software. So in the DevOps world, we use things like GitHub, for example, which is a managed service. It's a cloud service that we can plug into, that we can put all our code up into Git. It manages all of our versions of applications, etc., etc. And if I was to just mention in the kind of, if we were to look back in time, some of us might be familiar with some of the Microsoft tools. So there was something called Visual Source Safe that people used to manage their code in a similar way. It was used to check in and check out code and things. And the world has moved along. Microsoft to change Visual Source Safe to something else. And the dominant player in this area is the technology Git, and then in particular platforms like GitHub and Bitbucket. So that's our code. So our developers are typing their code, they send it up, and they want all the code managed, version and versions controlled, etc., etc. We move on to plan. So when we mention plan here, we're really talking about the kind of platforms, the cloud platforms that we can then use to deploy all our infrastructure, all of our code, etc., etc. Because cloud platforms don't just run our applications; they also store things like our code. So I've mentioned here a few of the popular ones. So we've got Azure, AWS, we've got common kind of hypervisor-based platforms as well. We've got VMware. You would also have platforms like Google, for example. There you'd have IBM's cloud. You've got Grids as well. Grids is our cloud. Grids is very comparable to AWS, Azure, VMware's cloud as well, and IBM's. It's a global cloud platform that we've built, that we've been running for many years. So that's quite self-explanatory. I think I don't need to go into too much more detail around that. We move on to deployment and deploy. So in the DevOps world, and what DevOps allows us to do is when we're deploying infrastructure, typically IT operations would have a person sitting at a control panel, and they would be clicking around saying, I want to create a new server, give it an IP address, give it all these kind of network details, and I want it to be Windows or Linux or whatever it might be. And then I'd click some buttons, and then I'd click on kind of create, and then wait for it to be created. In the DevOps world, what we do is we automate that. So again, this is all about automation. So we write some code or script, what we call script, and that allows us to just automatically create that virtual machine or server. And Terraform in particular, and Pulumi are very popular technologies, organizations. Well, Terraform is part of a company called HashiCorp, but they're very popular platforms for us to be able to do that. Now, why would we want to do that? Well, we might want to have an application that auto scales according to our rules. So in our application, we could call what we call some Terraform script that then creates more servers or gets rid of some servers. It's totally up to us. So again, it comes down to automation, and it comes down to less errors and increased speed. We don't have to raise a ticket that goes to IT operations. IT operations have to evaluate that ticket. They have to go through some various checks. Then somebody sits down at a control panel and creates that infrastructure. This is done via code, and the application can call that code itself. So it's all automated. And I think you can see it's a good example, because you can see the benefit straight away, that you can just literally have infrastructure created automatically, depending on various rules, whether it be scalability or it could be affordability. Maybe you've hit your budget for the month or the day, and you need to scale back your infrastructure. You can do that automatically through your application. You don't need to go and speak to someone in finance or business, and then IT operations, and then make a decision, and then they manually do it. So on the deployment side, platforms like Terraform and Pulumi, and obviously Octopus and Helm as well, they're used heavily. We use a lot of Terraform. We do a lot of Terraform, and we do that for various organizations ourselves. Then we move to the operate side. And what do we do on the operate side? The operate side is where we can manage the applications on those servers automatically. So platforms like Puppet and Chef and SaltStack will allow us to automatically deploy applications to our servers. So let's say, for example, we need to install an SFTP server or whatever it might be on one of our servers in our application. We can automatically do that from these platforms. We can do it programmatically. We can also do it manually via, or we can schedule, for example. These applications tend to run as what we call agents on our servers, and we normally have a server that operates it all. But the key difference to remember with deploy and operate: deploy is about the actual infrastructure, so that's the actual servers and network, and on the operate side, Chef and Puppet will then allow us to install applications on that infrastructure. These are heavily used, big, standard applications, are very well known, all of those three. On the monitor side, of DevOps, of any kind of mature application kind of deployment. On the monitor side, we've we've got all this infrastructure that's running. We've got Puppet and everything that's installed, that are installing applications on it. We want to monitor it. We want to see that CPU and RAM and things are healthy. We want to make sure that this space is not being eaten up all the time, for example. So we use some of these platforms. Now, Prometheus, as an example, is a full monitoring kind of solution. Something like Grafana, which again we use heavily, and I think some of you will be quite familiar with. Grafana is much more of a visualization engine, so it allows you to build charts, graphs, and allows you to dig into data, different data sources. So Grafana can kind of sit in front of databases, it can sit in front of log files and things like that. And it allows you to have a very elegant, very nice looking and very functional and usable series of dashboards, and you can get into detail on things. So the monitoring side is, I think, something that we all get straight away. But again, it's important to mention it as part of DevOps, because monitoring it can be automated as well. It feeds into our kind of base of automation. Let's get on to release, and I won't cover this in too much detail because we have a limited amount of time. But on the release side, we've got all-encompassing platforms like OpenStack. OpenStack has come a long way from when we first started playing with it. For example, we actually built a whole cloud platform on OpenStack. I think it's been 6-7 years ago we did that, but it wasn't ready for production release back then. So we went with an alternative for our grids platform, which is based on VMware. But on the release side, we've got all-encompassing kind of orchestration platforms that allow us to kind of do everything around cloud. I'll move on to test because I want to get onto the build and containers and things as well. So, when we have an application, when we're deploying an application, we want to test it. So again, when we're doing QA in our organizations, we quite often have a team that just does testing, and we do unit testing, we do user acceptance testing, UAT, as you guys know, we do operational acceptance testing. And in the DevOps world, again, we can automate much of this, not all of it. It's not quite possible to automate quite everything, but we can automate much of it. And again, what does that feed into? It feeds into us saving time and reducing errors. So we know Jenkins very well. We use Jenkins heavily, and so do many others. And what does Jenkins do? Jenkins automates the process of building the application. So traditionally, a developer would go to their machine, or maybe if they're a bit mature, they'll go to a build server they've got in the office, or maybe some hosted somewhere or in the cloud, and they do, they click on a few things, and then eventually they build their application. And I think most of us are familiar when you're writing code and things, you need to compile it. Generally speaking, you have to compile it. Some programs are interpreted, but we generally will compile that program. And then there might be some errors, and they have to debug it and go through this kind of cycle. Once we've got that correct, what Jenkins will do will automate that, and it will actually build the program, or build the application, and then deploy the application to the cloud. So if we look at the top of the screen, it will deploy it to AWS or Azure or Grids or VMware or IBM Cloud, for example. But what Jenkins will also do, and Argo and CircleCI, is that they will also do some testing. So we can automate some of our testing. So we can make sure that the application is running properly as it should be, without a person necessarily doing it. We can do it in an automated fashion. So again, we build some rules, we build some use cases, and these Jenkins and Argo and applications like that will just automate that and give us our results and say tick tick tick, it's all healthy, great, or here's an issue, here's a critical issue, or here's an issue that isn't critical, you need to look into it. So again, on the testing side, these tools don't just make our lives easier. The tangible benefits that they give us are that we save time, and we save on potentially large amounts of human error. So that's test, and then we go on to build. So on the build side, we've got some names there. Again, some of you will know maybe some of you use or you want to use. So we've got Docker, Kubernetes, we've got Red Hat OpenShift, and we've got Nomad. I'm going to concentrate more on Kubernetes here, but what I'm going to do is I'm just going to rewind a bit and actually explain a term or explain a kind of technology, and that is what we call containers or containerization. So on the build side, when we have our application, we will build and we'll send our application. It'll run on, our applications run on servers. Generally speaking, they'll run on a server. A server can be, a bare metal server, which not many people run anymore, but it could be a bare metal server. But it could also be what we call a virtual machine, a VM. Again, many of you will be familiar with these terms. There's another abstraction layer. And I always kind of mention this as technology goes further and further, we're abstracting. So we're kind of abstracting further and further away from kind of hardware, generally speaking, because software is getting. So we now have a concept called containerization. And I'm just going to very briefly explain what a container is. So again, remember the aim of this is to enable you to understand some of these terms and what these things are, because then when you see a new logo pop up next to build, for example, you'll understand straight away, oh, okay, this is organization or this application deals with containers. I know what a container is. Just 1 second, I'm just going to have a sip of water. So a container is similar to what we call a virtual machine, but the thing with containers is one of the key items to remember is containers are portable. So a virtual machine, if you're running a virtual machine in AWS, for example, if you want to run that virtual machine, that server, somewhere else in Azure or any other platform, it's not necessarily just going to work if you just pick it up and move it. You can migrate across, but it's not necessarily just going to work. And some of the settings you might not have. There are ways to do this. But the elegant thing about containers is that they're portable and you can literally run them wherever you want. So you could take a container that runs in AWS and run it in Azure or Grids or IBM Cloud, for example, or Google Cloud. So that's one of the things. The other key thing to remember with containers is that a container is self-contained. It runs, the whole application runs within a container. So all the settings that an application has, our applications have, they're all within this container. So it's independent. It doesn't need to go to the operating system, so Windows or Linux, to say, where is this file? Where is this resource, for example? It's all within the container. So that's a very important point to note, because it makes them portable. It makes them, you can run them wherever they want. They're not dependent on the operating system. Our applications typically are tied to the operating system, which means that if we want to move them somewhere else, we need to modify the operating system that we're running somewhere else, and we have to make sure it's built correctly, and we have to test it and everything. With containers, we don't have to do that. That's the key thing to remember with containers. And within the container, we can run whatever we want. We can run in theory, we could run a whole massive application within one container. And that would be fine technically, and it would work, if it was all tested. We could also, and what we're doing more of nowadays, and when I say we, I'm talking about the whole kind of community of people that use Kubernetes or containerization, is that what we're now doing is we're splitting up our application into containers, and then making our applications much more nimble, fast, and scalable by putting our business logic into different, what we call containers, mini kind of applications, and then we're running them on-prem. We can run them on-prem, but we can also run them on the cloud, in the cloud, sorry. So Kubernetes is one such technology that allows us to have containers. Kubernetes was originally a Google thing, and then they released it out to everyone. And it's something that, again, we've got a huge amount of experience with and expertise with. But the key thing is on the container side of things is that just remember that containers are these kind of light little kind of mini kind of applications that are independent of the infrastructure they're running on. They can run anywhere. So in theory, we could have an application that runs, some of it runs on-prem, some of it runs in AWS, some of it runs in Grid, some of it runs in Azure. We could do that technically if we wanted to. In reality, we don't generally spread our applications across so many platforms. We might spread them across a couple. But yeah, sorry, that's containers, and that's covering off this kind of build part of things. So I've kind of gone through this, kind of steamrolled through all of this fairly quickly, and time's gone by very quickly indeed. And I appreciate we've got a few minutes left. So hopefully, the aim of this was not to go into a huge amount of detail and kind of do an kind of all-encompassing view. This is about a highlight, a description of what DevOps is, and hopefully some of these sections that I've kind of described to you, and some of the organizations and some of the base kind of ideas will ring home and be of benefit. That's the whole point. This, hopefully they'll be of benefit to you. Like I said, what we can do, if you want to go into any more detail, just contact me, contact Sandy. We're more than happy to talk about any of this further and explain it further. Obviously, really interested that if any of you already use any of these platforms, any of these technologies, we'd love to hear more about your experience with them as well. Certainly with regards to pros and cons and the effectiveness of them. What we'll be doing is we'll be doing a follow-up, a kind of follow-up breakfast briefing, maybe in person, depending on all the kind of COVID rules and things, where we can go into specific use cases. And I think, again, use cases help us kind of visualize what a technology or any kind of or a platform, whatever, what they actually do. And yeah, I'd love to go through that. Love to go through that with you. So I think we've got a minute left. Okay, so just to finish off, I think it's worth noting that we've got this code, plan, release, deploy, operate, monitor, test, and build. A very important point to remember with all of this, and with regards to DevOps, is that DevOps isn't necessarily everything together. It doesn't have to be. DevOps could be just one or two of these taken out into your organization or a client's organization or a partner organization. And you can say, and you are genuinely running or operating DevOps. Yeah, DevOps doesn't have to be everything. And certainly, we see lots of organizations that don't necessarily, run everything that you see here, but they do a very good job of their DevOps. Yeah, so DevOps can just be distinct pieces of what we see on the screen here, and done very well. So, for example, using something like Terraform to script our infrastructure, for example, you don't have to then use Puppet and Chef to do all the application automation. Maybe you do that manually. So I think hopefully what you get from that is DevOps is a journey, and that journey is normally done by discussing, talking, seeing what the business priorities are, and then coming up with a plan to implement DevOps. And if you're already running DevOps, then you can review that, and you can look at the tools that you use and how they affect your organization. So I've been blabbing on for half an hour now, and it's 11 o'clock, so we've come to the end. I hope, like I said, I hope this has been of benefit to everyone. Feel free to contact us. I hope you've enjoyed I hope you've had your tea or your coffee in your tumblers. Mine's gone cold now, so I'm going to make another one. And hopefully you haven't overdosed on all the sugar from the macarons. But yeah, hopefully I'll personally see you all at some point. Enjoy the day and enjoy the weekend. Thank you very much.